Alright, so last class we took a look at various representations of graphs. So we're going to start with a warm-up to recap that and then move on to some more vocabulary and representations. Alright, so we're going to create a graph that goes with this set of vertices and this set of edges. So as you can see, I've made those 6 vertices and labeled them A through F. Now all I need to do is draw the edges as listed. So the first one is AD, so I'm just going to connect A to D. And then I have BC, BD, CA, remember, it's okay to have lines cross. If you prefer, you could draw it going around the outside of B, so you could have done this instead if you don't want the lines to cross. But again, it's perfectly okay for the lines to cross. And then we have CF and FD. Okay, so there are 1, 2, 3, 4, 5, 6 edges. So this is my graph. Now, my question for you is this graph connected? Well, this point down here, E, is what's making it not connected. So this is not connected. If vertex E was eliminated from the graph, then this would be a connected graph. Is this graph complete? Now this, since it's not connected, it cannot be complete. Remember, complete means that every edge is, my apologies. Complete means that every vertex is adjacent to every other vertex, meaning every vertex is directly connected to every other vertex. Okay, so this is not connected and not complete. All right, the second representation we had was from an adjacency matrix. Now remember, this represents ABCD and ABCD. And a 0 represents no edge between those two vertices, and a 1 represents there is an edge. So if we wanted to go through and list, the vertices here are ABCD, as shown in my graph below. The edges are, all right, there's a connection between A and B, so we're going to have AB or BA. So AB or BA. So that takes care of this and this. Next, we have AC. AC. So AC, I'm going to draw that connection, and that takes care of those two ones. The next one that I see is going to be BC right here. BC. And the last one is going to be BD. Which takes care of both of those. BD would be this. So this is a sample of what that graph could look like. Again, if you don't want the lines to cross, I could draw BD going around this way instead. Okay, but this is a final graph. All right. Let's take a look at some more graph vocabulary. So the number of edges that have a specific vertex as the endpoint is known as the degree or valence of that vertex. We're going to stick with the word degree, so underline degree. But the book uses both, so I wanted to give you both just in case you saw it in a homework assignment. All right, so we're going to find the degree of each vertex. Now you can write it next to the letter, or you can make a list. So if I go ahead and make a list, A, B, C, and D. Now what are the vertices? So I look at point A right here, and I say how many edges are connected to point A? Well, I've got this edge here is 1, and this edge here is 2. So the degree of A is 2. There are 2 edges touching vertex A. So what's the vertex of, or the degree of vertex B? Well, that would be 1 edge, 2 edge, 3 edges. So the degree there will be 3. How about C? C has 2 edges touching it, so that's going to have a degree of 2. And D has a degree of just 1. So it's 2, 3, 2, 1. Take a minute and try to figure out what the edges, how many edges are touching each vertex in the second graph. So what's the degree of each vertex here? A, B, C, D, and E. Okay. So A has 2 edges touching it. The degree of A is 2. B has only 1. C has 1, 2, 3. D has 1, 2, 3, and E has 3. All right, one thing I want to point out with E, there's one here, and a different one here. Okay, so there's a connection from B to E, from D to E, and C to E. There are 3 direct connections there, so the degree is 3. Okay, so that's degree. There's another way to tell what the degree is, and that's from an adjacency matrix. So before we learn how to do degree from an adjacency matrix, let's go through and write the adjacency matrices for these 2 graphs. So remember, it goes A, B, C, D along the top, and A, B, C, D along the side. Okay, now looking at this graph, is A connected to A? And that's a no, so that's a 0. Every no is a 0, every yes is a 1. There's a connection from A to B, so that's a 1. Is there a connection from A to C? Yes, there is, that's a 1. And from A to D, that's a no. And remember, the first row is the same as the first column, so 0, 1, 1, 0. Going down, we're going to have 0, 1, 1, 0. All right, is B connected to B? No. Is B connected to C? Yes. Is B connected to D? Yes. So that's 1, 0, 1, 1. Going down, we have to have 1, 0, 1, 1. Is C connected to C? No. Is C connected to D? No. And then is D connected to D? No. All right, so this is the adjacency matrix that goes with this. And I just want to point out, if we go back to the second warm-up problem, right back here, this is the exact same adjacency matrix as what we just wrote. So you can see the graphs look different, but they have all the same connections. So they're technically the same graph. All right. Now here's the nice thing. The degree is just the sum of all the numbers in a single row or column. So if I add those numbers together, I get 2. The degree of vertex A was 2. If I went down the column, that would also be 2. So A would be 2. Therefore, the degree of vertex B is 3. The degree of vertex C would just be 2. And the degree of vertex D would be 1. Okay, so you can just add up all the numbers in each individual row to get the degree, or you could add up all the numbers in every individual column to get the degree of each vertex. All right, so the adjacency matrix that goes with graph 2. This one's going to be a 5 by 5 because there are 5 vertices, and again it goes A, B, C, D, and now E along the top, A, B, C, D, E along the side. Okay. Is A connected to A? No. Is A connected to B? No. Is A connected to C? Yes. A connected to D? Yes. A connected to E? No. So we've got 0, 0, 1, 1, 0. Is B connected to itself? No. Is B connected to C? No. Is B connected to D? No. Is B connected to E? Yes. All right, C. Is C connected to C? No. Is C connected to D? Yes. Is C connected to E? Yes. D connected to D? No. D connected to E? Yes. E connected to E? No. And now if I look at the degrees, if I add up all the numbers in each individual row, I get the degree of A is 2, the degree of B was 1, the degree of C is 3, the degree of D is 3, and the degree of E is 3. And that should match what we had on the previous slide. So that's how you can find degree. Finding degree should be really, really easy to do. You're either looking at a graph and determining it, or looking at the adjacency matrix and determining it from there. Okay, so that's degree. All right, the last new thing we need to talk about are multigraphs. Now, multigraphs are graphs that have more than one edge connecting the same pair of vertices. Okay, they can also have loops on them or an edge that connects a vertex to itself. So here's an example of a loop. All right, and that counts as a single edge, but it's connecting B to itself. So we want to write an adjacency matrix for this graph. Now there are 4 points on it, 4 vertices, so we're just going to have A, B, C, D. So it'll be a 4 by 4. But now instead of having just zeros and ones, we can have bigger numbers to represent more than one edge coming out. Okay, so if I look at vertex A, is A connected to itself? No, there's no loop there, so that's still a 0. All right, so no edge is still represented by a 0. But if I look at A to B, I have one edge there connecting A to B. So there's a 1 and a 1. A to C has no direct connection, so that's a 0. And now herein lies the difference. A to D, there are two edges here connecting A to D. So now under AD, I put a 2, or under DA, I put a 2. Okay, so that represents that there are two edges connecting. All right, B is connected to itself by a single loop, so there's a 1 under the BB. Is B connected to C? Yes, by one edge. And is B connected to D? No, not directly. Now, is C connected to itself? No. Is C connected to D? Yes, by two separate edges. One here, one here. Okay, so there's a 2 there and a 2 there. And last, is D connected to itself? No. And again, we can find degree the same way we did before. The degree of A will be 3. The degree of B will be 3, which could be a little bit confusing because it looks like there's 4 edges, but that's because these two pieces right here are coming from the same edge. It only counts once when it comes to the degree. All right, the degree of C is going to be 3, and the degree of D is going to be 4. All right, so that's a multigraph. Now I'm going to give you an adjacency matrix, and we're going to draw the graph and then find the degree from there. Okay, so here we go. Create a multigraph for the matrix below, then identify the degree of each vertex. Now you see there aren't any letters here, but you can easily add on your own letters. So this goes A, B, C, D, E, and A, B, C, D, E. And remember, as you go across a row, you're technically going down that same column, so you can kind of cross things off as you go if you want. All right, so we have a connection from A to A, which means we have a loop around A. Okay, so that takes care of that. Now we're going to deal with A goes to B, but there are two edges. So let's draw two edges. And this is where drawing slightly curved lines is going to be helpful. If you try to draw two lines that are exactly the same, well, you're not going to be able to tell that there's two lines there. So that takes care of this 2 and this 2. There's no connection from A to C or A to D, but there is a connection, a single one, from A to E. So we'll draw that in. That takes care of that and that. Okay. Now we're going to take a look at row B. So we have B is not connected to B, but B is connected to C twice. So again, we need 2 going from B to C. So that takes care of this 2 and this 2. B is connected to D one time. So that goes like this. And that takes care of that and that. And that takes care of the entire B row because there's no connection between B and E. Now looking at row C, we have no connection from C to A, but we have a connection from C to C. So we need a loop around C, like that. So that takes care of this. And we have a connection from C to E. So I can draw straight across like this, but if I'm trying to make it trying to avoid crossing lines, you could always go like this instead. Okay, either one's fine, they're both the same thing, but as far as making it a legible graph, you might want to try to avoid crossing lines if you can. Okay, so that's from C to E, so that's this one and this one. Now we're in row D. The only number I haven't crossed off is the 1 under DE, so I need a line segment from DE. So that can go right there. And last but not least, I have to have a connection from E to E, so a loop around E. Alright, so that's the multigraph. Now if I said go through and find the degrees, well the degrees I'm going to write in red next to it, so the degree of A is going to be 4, because I have 1 plus 2 plus 1 is 4. The degree of B is going to be 5. The degree of C is going to be 4. Again, I'm just adding the numbers in each row. The degree of D will be just 2. The degree of E is going to be 4. Okay? That's it. So your homework is to finish the assignment from page 169. And then also add on these 4 problems here. So you're doing page 179, 10, 12A, and 13. All right. If you have any questions, email me and we'll go over this in class tomorrow.